Welcome to my channel. Today I'm going to talk about discrete probability distribution from your A-level course. I'm Naveen Podal. I'm going to talk about discrete probability distribution. Okay, let's begin. The probability distribution, which explains the probability of a discrete random variable, is called discrete probability distribution. So the probability distribution that is associated with discrete random variable means what kind of variable is the discrete random variable. The first question that must come up in your mind should be, what is discrete random variable? So let's talk about discrete random variable. If a random variable can take only a finite number of distinct values, then the random variable is said to be discrete random variable. For example, if we are talking about the number of children in a family, number of patients in a doctor's surgery, number of defective light bulbs in a box of 10, a number of mobile phones, number of television in a house. So there are different cases we can take as example of a discrete random variable because they take only a finite number of distinct values, either 0, 1, 2, 3, 4, and so on. So the probability, talk about discrete probability distribution. If we take an example of toss of a coin, then the number of head appears. If we count the number of head appears, then the number of heads could be any integer from 0, 1, 2, 3 or greater than 0. We cannot get 2.5 heads, 1.5 heads, 2 heads. We can get 2 heads, 3 heads, 4 heads, and so on, but we cannot find 2.25 heads. So therefore the number of head appears must be our discrete variable. The probability distribution associated with this kind of discrete variable is called discrete probability distribution. Let's talk about an example of 3 toss of a coin. The tree diagram associated with 3 toss of coin is shown over here, and what you can observe from tree diagram is that in each and every toss you have 2 possible outcomes, head and tail, and each and every outcomes are toss are independent of their previous toss. In the first toss we have either head or tail, and in second toss, whether we have head in our first toss or tail in our first toss, it does not matter of getting head or tail. It has same probability, that is, it is independent. The second toss is independent of first toss, and likewise third toss is independent of second toss. The probability of head and probability of tail remain same. And so what you can observe is through a random variable, if we suppose x as a number of head appears, then we can see there are 3 heads in 3 toss, 2 heads, 2 heads, 1 head, then 2 head, then 1 head, then 1 head, and then no head. So if we tabulate this information, it means random variable x equals to 0 means no head, and no head gives you only one option, that is in green color, that tail, and tail. So the probability associated with that is 1 by 8. Likewise, probability of one head is shown as light blue color, and you can see tail, head, tail, head, tail, and tail, head, and the probability associated with that is 3 by 8, and so on if you see further. And So how many types of discrete probability distribution? There are really different type of discrete probability distribution, but I want to confine myself in A level course, and this A level course explain discrete probability distribution. uh, mm, two discrete probability distribution. One is binomial distribution and another is geometric distribution. The binomial distribution is related to R successes. We are finding the probability of an event having R successes, but geometric distribution is related to we are searching for the probability of false successes. So we are talking about these two probability distribution in this course. And binomial random variable and binomial probability distribution. A random variable x is said to have binomial probability distribution with parameter n and p if it satisfies following. So these 4 points are most important point in order to a random variable satisfy binomial distribution. So there are n repeated independent trial. N is finite. There are just 2 possible outcomes for each trials, namely failure and success. So the probability of success p in each trial is constant, as probability of failure is complementary, and that is also constant in each trial. Let's talk about building normal probability distribution. From our previous example of 3 tosses of a coin, we have got this 8 different outputs, and this 8 different output we can summarize as in the table. In this table, I'm trying to explain how the number of head be selected. So if we choose no head be selected, then there are exactly one number of way to select no head, that is 3 combination 0, combination of 3 things taking 0 at a time. Okay, likewise 1 head, combination of 3 things 1 at a time. 2 head, combination of 3 things 2 at a time. And 3 heads selected is combination of 3 things taken all at a time. So is the probability of no head is 1 by 8, 1 head is 1 by 8, 2 head is 1 by 8, and 3 head is 1 by 8. But there are 3 different combination for 1 head and 2 head. So their total probability become 3 by 8 and 3 by 8. Let us explain this information in this table. And this table is explaining the probabilities that we have discussed in earlier table in terms of binomial probability distribution. And finally we come to the conclusion that in a binomial probability distribution which satisfies above mentioned 4 conditions, is that probability of x is equals to x is the combination of n things taken x at a time times probability of success to the power x times probability of failure to the power n minus x. This is the formula that we can derive from these experiences. And this is the formula for binomial probability distribution for x number of successes. X number of successes means x number of heads, or x be the random variable that take the value x equals to x, and which completes this introduction about binomial distribution and discrete probability distribution. And I will be coming up with other example and explanation in later videos. Thank you for your patience to hear me to watch this video.